Hi, my name is Clifford Herbert and Marcus, 05DKA 19F1060. So I'm from Group 4 and this is my group member, Muhammad Iqmal bin Bujang, and me, Clifford Herbert, and Jennifer Lantang, Azim Adli bin Edeni, and Militan Johnny. So this is our project divided. So I'm going to do for Slab B-C 3 until 5. So this is our AutoCAD drawing that we've done, and this is my calculation for slab BC until 35. So my QK is 1.90, FCK we pick 25, and then wall height is 3.4 meter. So for my length 3 until 5 is 3.80 meter, and for B until C is 3.00 meter. So for my type of slab is two-way slab. For case is I'm going to use case 2, that is one short edge discontinuous. For my QK is 1.90, FCK 25, fire resistant is 120 ray, and for exposure class is we're going to use XS3. So first of all, I'm going to calculate the ratio of slab. Ratio of slab is Ly divided to Lx, and I've got 0.8, that is less than 2.0, that is mean two-way slab. For specification, my thickness Ly divided to 35, I've get 1.08.57 millimeter. So I need to use less or higher than it. So I'm going to use 100 mm for thickness. Permanent GK action, reinforced concrete times by H plus finishing. So 25 times by 0.1 plus 1.0 for finishing. And I have got is 3.5 kilonewton per meter square. Reinforced concrete, we're going to use 35 kN per meter cube, and finishing is 1 kN per meter square, that is tile, from chapter 1 page 13 table 1.5. Variable QK 1.90 kN per m, and then for design action I have got is 7.58 kilonewton meter. For design life, I have got we use 50 years building structure and other common structure from chapter 1 page 9. For bending moment coefficient, BSX and BSY. For negative, I've used 0.039, and for positive is 0.029, and BSY 0.037 and 0.025. So for moment short span, for the negative is 4.27 kilonewton meter, and for the positive is 3.17 kilonewton meter. For the moment long span, MSY, for negative is 4.05 kilonewton meter, and for the positive is 3.0.6 kilonewton per meter. For the material, characteristic strength of concrete, FCK, is 25 kilonewton per meter cube. For the steel, FYK is 500 newton per millimeter square, and unit weight of reinforced concrete is 35 kilonewton per meter cube. By assumed bar, we use 6 millimeter. slab thickness I've got is 1.08.57 millimeter, so I need to use less from it, and 100 millimeter is the best one I have chosen. So for durability, fire and bond requirement, exposure class XS3, and fire resistance is 120. So minimum cement content is 340 kg per meter square from appendix C. Mean cover with regard to bond is 10 mm. Mean cover for durability duration 45. From 45 mm, we choose that one is from chapter 5 page 91. So by assuming it, we calculate it, and we have 12 mm. So we use that one. For allowance in design of deviation, AC depth is 10 mm, C norm is 57 mm, and for the main reinforcement, effective depth is for dx is 40 mm, dy will be 34 mm. Minimum and maximum reinforcement area, AS bin, I've got is 66.77 millimeter square per meter, and AS max is 4000 millimeter square per meter. So for AS min, I use H8 to 300, and that is 168 millimeter square per meter. Short span for mid span is 3.717 kilonewton, and for the K is I've got is 0.08, that is K bar, less than 0.107, so the compressive strength is not required. So for the Z, I have got is 0.92, is higher than less than 0.95 diameter, is so I need to use Z is below from 0.95, that is 0.92 D. So the calculation it will be continue the same one until here, until the long span. So this is the table, location as required, as provide, hash bar minus C per C, length, number of bar. So for the middle short span, I have got is, for the number of bar is 13, continuous short span 21 bars, middle long span 20 bars, continuous long span is 17 bars, and for the AS min, for the short is 11 bars, and for the long is 13 bars. So for overall of total length of each bar is 39 millimeter. For LB, LT is 37.8 meter, UB will be 60 meter, LT for long span is 38.76 meter. So for AS min will be 33 meter bar, and long will be 49.4 meter. So this is the drawing that I have done for bending moment and the SFD graph. So